Tēnā koutou katoa and hello everybody. Welcome to the Lentil Intervention Podcast. My name is Ben Adelberg and I'm coming to you from Tamaki Makaurau, Auckland.
And g'day, I'm Emma Strutt and I'm currently coming to you from Gungaloo Country in Queensland. And before we dive into the conversation today, I'd just like to acknowledge the traditional custodians of country throughout Australia and their connections to land, sea and community.
The Lentil Intervention is an Australasian educational and advocacy platform dedicated to raising awareness about the current climate and health crisis.
And on this podcast, we invite guests to chat about topics that will inspire you to take action to improve your own health and the health of the planet.
So please subscribe to and share this podcast and visit our website for the full show notes.
And don't forget to buy us a coffee if you'd like to support our work.
Right, Season 2, Episode 43, and we're back with the Drift Lab, which, by the way, is a part of the Institute of Marine and Antarctic Studies at the University of Tasmania, and another couple of inspiring budding scientists to teach us oldies more about what we don't know. So, Emma, over to you.
Yep, that's right. So today we are again lucky to be joined by two wonderful guests, Lillian Stewart and Harrison Talarico. Lillian is a PhD candidate and Harrison is an honours student at the Uni of Tas. And these two amazing humans are the fourth interview in a series from the brilliant team at Drift Lab, and they will be discussing plastics and impact on marine life. It's our last conversation with the Drift Lab for now, but I'm sure we'll have plenty more interviews in store because they do some really fantastic work. So Lillian, Harrison, thank you so much for joining us today.
Thank you so much for having us.
Great to be here.
Awesome. So just like we have with all our previous guests, firstly, Harrison, your first ever podcast, so we promise we'll go a little easy on you. Lillian, I think you're a bit of a seasoned pro. This is your second one?
Yes, I have done a previous episode with the Ocean Protect team.
Which is a brilliant podcast, so check that out.
That's right. Brad Dalrymple.
That's the one, yeah. Great team.
But anyway, Lillian, Harrison, thank you so much again for coming onto the show. Let's start off with your personal stories of how you came to be at a Drift Lab, and I take it obviously your personal journey through the world of science.
All right. So I guess to paint a candid picture of how I got here, I'm not going to lie, I was a bit of a strange kid growing up. From a really, really young age, I was just fascinated by birds. According to my mum, my first word was bird, or at least some kind of child variation of that. And I was completely obsessed with my pet chickens, and I remember taking them in one day in grade 6 for show and tell. So obviously I was the cool kid in school. I also just really love science, and I love learning about the natural world. And so my plan, if you could call it that, was to just find a job that I guess fostered that fascination. And I guess like so many, I grew up watching Sir David Attenborough's documentaries. And so there was sort of a spark in me that had been ignited from that. And so I guess fast forwarding to my university years, I did a Bachelor of Science at the University of Tasmania. I majored in geography and marine science to keep it broad because I still had no clue what I was doing. And I'd kind of hoped that I'd figure that out by the end of the 3 years, but didn't. Still had no clue. But throughout that degree, the wonderful Dr. Jennifer Lavers lectured some of my classes. And I very quickly became pretty much just amazed by the research that she was doing. And she was one of the most kind-hearted and passionate people that I'd sort of met. And so by the end of my undergraduate, Jen reached out to me with a one-sentence email asking if I was looking for an honours project. And I still had no clue. So I thought, why not? This is a great opportunity. I was going to be working with Jen, so that was a bit of a dream come true. And the project basically was working with birds and their vomit. And so I just thought that was pretty cool. That sounds like an absolute hoot. I'll give that a crack. And I'll get into the details of that project a little bit later. But I've since finished my honours. And this year I was fortunate enough to receive a PhD scholarship to continue studying with Jen and a Drift Lab. And I'm now looking at waste management and marine plastics on remote islands and perhaps some of the ways we can sustainably overcome some of the challenges in that space.
Wow, what an introduction. Harrison, tough call to follow that one up.
Yeah, I mean, like Lil, I've always kind of been interested in the natural world. Some of my earliest memories was sitting on the couch with mum and watching nature documentaries. But I guess my pathway was a little bit unorthodox in that I first, out of high school, studied a Bachelor of Communications, majoring in public relations. So I kind of graduated that and sort of tried to kind of make a pathway to, in that space, and ended up getting a job as a travel agent in sales. So lucky I kind of got out of that at this point. But no, so I worked in internal comms at the travel agency, and it sort of was. I was a little bit feeling a bit unmotivated because it wasn't really necessarily a pathway that I wanted to follow. So this was when I was still living in Melbourne. I grew up in Melbourne, and I remember just looking up potential university degrees that I could do to, just get me more motivated and more passionate about the work that I was doing. And I came across the Bachelor of Science at University of Tasmania, and sort of inquired about it, and applied for it and got in. And next thing I knew, I'd moved down to Hobart to start my undergrad, majoring in zoology. So I spent 3 years doing that degree, and when I graduated, I was trying to work out what I was going to do next. I think I always wanted to do honours straight away and just kind of ride that momentum. So I decided to apply for honours and inquire with a few different supervisors about potential projects. One of those supervisors was Jennifer Lavers, and it was regarding the projects about short-tailed shearwaters and the migration of short-tailed shearwaters. And we can get into the details about my project soon, but I remember but short-tailed shearwaters are basically like a seabird, and I remember one instance of going to this place in Tassie, Bruny Island, on the Neck, and seeing all these birds come in from their daily fishing expedition. They go out into fish in the day and then come back in at night to their colonies. And I remember going in one day and just seeing like the sky kind of turn black with all these like amazing birds that were just coming in and flying around and squawking and running everywhere. And that kind of really held in my mind for a long time. So when I saw this project with Jen about short-tailed shearwaters and their migration, I was really excited about the prospect and sort of jumped at it. And here I am, more than 12 months later, I guess. So, I sent her an email in October 2020, and here we are now, and I'm just about finishing my honours. So I've got about 2 weeks left and my thesis is due. So it's a relatively stressful time. It's been a wild ride.
And I think by the time we've published this, you will have been completed. So congratulations on that.
Thank you.
Now, you did mention, when you first studied, communications, and Dr. Jack Audie, made a really good point about the importance of scientists being able to present, to tell the story. So before we carry on, Lillian, on your Adrift Lab bio, it states that you've already had numerous wins despite only being 6 months into the PhD candidature. And that involves communication, doesn't it? Global Biodiversity Festival, the Hobart Beaker Street Festival, Catfish Creative in Sydney. Tell us a little bit more about those little initiatives that you've been a part of.
So, you're absolutely correct. Science communication is quite a big part of what we do. And we're very proud that Adrift Lab really fosters that and pushes us, I guess, to get a little bit outside of our comfort zones and do things maybe we weren't super comfortable with doing at first, like just public speaking. I remember I was such a shivering, nervous wreck when I did my very first talk to the public, but that has since changed, and now I'm doing things like podcasts, which is really cool. There was, you mentioned Beaker Street, which is an art science festival that happens in Hobart, and has an amazing array of panelists and speakers and engagement activities and things like that. And so we were really lucky to be part of that this year. I spoke alongside Jen and Megan, who you featured on a previous episode, and a local artist, Lucian Ricard. And we spoke about something that's, I guess, not as, maybe not as widely talked about, but it's definitely widely experienced. And we spoke about eco-grief, and that was a really fantastic opportunity to speak about something a little bit uncomfortable, but do it to the public and just talk really honestly about maybe some of the less, less recognized things that we go through as scientists in this space, working in the environment and, climate science and marine science. So that was really fantastic. I really enjoyed that one. We also did the Global Biodiversity Festival, which Harrison was also part of as well. And that was really cool. We did a quick chat about some of the projects we've been working on, and that was just really great. It was, I think, 160, I'm not sure if that number's correct, but 160 conservationists, communicators, scientists, photographers, anyone working in the natural space was part of that. And so that was really cool. It was a 3-day festival, non-stop, run out of America, sorry. And yeah, it was just really cool. There was so many cool people speaking there. And yeah, people like Sylvia Earle were also on the panel. So to be part of that was quite humbling.
You raise a good point, actually, Lillian. You guys, both of you, are at the coalface of this, dealing with these kind of ecological issues day in, day out. So just before we kind of dive into your projects, how do you personally deal with this? Like, obviously you'd be experiencing some eco grief and climate anxiety, and the plastic problem is huge. So how do you guys deal with that as science students?
Yeah, it's an interesting one. I think I would say, I don't know if Lil would agree with this, but Lil's probably more on the. It's more jarring, Lil's, I think, field work, because I think because she's dealing with plastics. I think, and you can really just kind of see the impacts really quite viscerally. With my research, it's not quite as jarring, I don't think, but I mean, obviously, it's just part of being a scientist, right? I mean, the world is changing for the worse, and our biota are going to suffer for it, and it sucks. But I guess like the best thing you can do is research and try and make a positive difference. And it sounds kind of bad to say in some respects, but it's kind of just, it's good data in some ways. Like when you see when things are happening and they're bad, yes, they're awful, and you can be really upset about it and break down for it. And there's a time and place for that as well, for sure, being really upset. But at the same time, you can kind of get buoyed by the data that you're collecting and knowing that this is actually going to make a positive impact. By collecting it and analysing it.
I guess for me, this is a really loaded question. How do we cope? Sometimes I don't know if I do. There's been days already. I'm only 8 months into a PhD. That's quite a loaded topic. I mean, I'm going to be hopefully able to travel to some fairly remote island locations, and the places that I'm hoping to get to are very much bearing the brunt of a catastrophic plastic pollution problem. And there's been days where I've seen photos that have been taken of my potential sites, and listened to people's stories that are experiencing this. And I've just had to close my laptop and go home on a couple of occasions, because it is horrible. It really is horrible. And being scientists on the forefront of one of the many issues that are going on today, we don't get any training on how to deal with that. It's starting out as a young person going into this, I had all these hopes. I just wanted to work with birds and live a David Attenborough documentary, really. But a lot of the things that I really hope to do, I can't, and I'll probably never see. And things are changing at a rate that our collective action perhaps isn't addressing fast enough. And so I guess one of the ways that I'm able to cope with this sort of thing is by having a really supportive network. So, I mean, another shout out to Adrift Lab. We all really understand and are really quite open with what we're feeling, what we're experiencing, and how we overcome those things. And so to have a network that is so fantastic really does help. But also just being able to, I guess, get better at switching off. So when I go home, whilst I continue to, read articles and follow people on Twitter that are doing different things in a similar space and that sort of thing, I really am trying to just find ways that I can just maybe put in my headphones, listen to some music or a podcast or something, and do some gardening, or just something that's so different to what I do Monday to Friday. So that's a really interesting question, and I'm really hoping that conversation gets a bit more airtime from a lot more people, because it's something that's very real.
Yeah, and really important for future students that are considering going down this path. So they're good tips that you've mentioned there. Sometimes it is good to just kind of shut the computer and tune out for a little while and watch a comedy or listen to some music, or just something outside of that space, so it doesn't get so overwhelming, because it is tough.
Yeah, I shamelessly am going to admit this. I'm an avid lover of The Bachelor and Bachelorette, and so Jen hates hearing me talk about it, but sometimes you've just got to have an outlet, as trashy and cringeworthy as that sometimes.
I was just going to say, I used to work at QIMR Berghofer, so like some of the best scientists in Queensland, and in the lunchroom, they'd always be talking about The Bachelor. So maybe that's why. I just need a bit of downtime.
Sounds like we've got our next potential guest for the show. No. But, you know, I do wonder if, you know, as you get sort of more experience, like when I say, you know, you've been more years in this field, if you start desensitizing to a lot what you see. But, you know, the conversation we had with Dr. Jack Orty, I mean, he got emotional telling us the story of what he had seen on one of the islands. And maybe you don't get desensitized. So it's about how you deal with it. And if you don't, then it's inside. It's not going anywhere. We had a whole episode on this with Dr. Sally Gillespie on dealing with eco grief, and yeah, it's a big thing, and I think Harrison made a very, very important point. It's something that's always stuck with me. The whole thing of hope, grounded hope, and you know, people like yourselves, whilst you're being exposed to what a lot of us will never see, because you're going to remote locations that is inaccessible to most of the population, but you're also in the same space that you're actively contributing to make a change. You know, data is important. Science is what drives a lot of decisions and policies and so on. So, you know, I guess in a long-winded way, it's you guys are standing up to it. You know, you're putting your hand up and saying, I'll deal with it, you know, because you have to somehow.
Yeah,
so,
absolutely.
Yeah, it's a challenge, isn't it? It's that balance. You don't want to see it, you don't want to deal with it, but you're in that unique position to be able to lead that change. And we're going to talk about some of that, but that's the space you're in.
Absolutely. And if I'm allowed to just add a little bit extra to this conversation, we've definitely gone down a rabbit hole with this one. But even though I still have no clue really what I'm doing with my life, kind of just living in the moment, I have definitely recognized the importance of really effective science communication. And I guess being able to develop my skills in that, being in this space, is probably one of the most valuable things I can do. I mean, there's a lot of preaching to the converted in science. We create data, we analyze that, and we publish that in a scientific journal, which is fantastic, and it's one of the perks of being a scientist. But one of the things that I think needs to develop a little bit more, and it's definitely getting a lot better, is being able to convey that information in a layman's way, in a way that the general public can understand, and most of the general public will be able to understand, because they're the ones that really need to hear what's going on and why we're doing the work we're doing. And so that's, I think, something that I'm really hoping to get a lot better at and go down the track of when I've done with this project.
Yeah, if I can add something also. Yeah, I think in some respects it's like you have to kind of realize that, you know, to help deal with this eco grief, you have to realize that things aren't going to go back to the way they were, and things are going to change for sure. But I think you just have to, I don't know, it seems a little bit dismissive to say accept that, and I don't want to be dismissive, but it's sort of, you have to acknowledge that, I guess, and then make your decisions and base your research around the fact that things are going to change and that things are different, and that we're never going to go back to this perfect place of, you know, absolute biodiversity. And I want to kind of reference what Lil's doing, but maybe we're going a bit far down. Yeah, like we should talk about what she's doing first. But it's, you know, the fact that these plastics are washing up all over these remote beaches, and what are the best ways that we can deal with these plastics. And I think Lil can talk much more about that, because that's part of the project. But yeah.
Yeah. All right. So let's dive in and talk about the project, Sam. But you made a really good point there. Like, we're at the stage now where we know we can't just do mitigation. We have to start adapting. The world is going to be different, and we need to, like, it's not a defeatist kind of thing to acknowledge that. It's now we need to put our boots on and get to work at doing the best we can with the situation we've got. So yeah, anyway, that's my ramble. Lillian, you've just returned from Lord Howe Island. You're currently in quarantine because of it, but that's a beautiful spot of the world. Huge plastic problem though. So tell us about your time there, and generally a bit more about your project.
So first of all, being able to do field work in a COVID climate is quite a privilege. So I'm very, very grateful that I've been able to do that. And yes, I am in home quarantine at the moment, halfway through. So yeah, we're getting through that one. But I was able to go to Lord Howe Island, which is about 500 or 600 kilometres east of New South Wales in Australia. And this was a phenomenal opportunity. It was one of the most just breathtaking places I will probably ever go. And despite there being every seabird you can imagine and like mountains that come out of the ocean and all these just prehistoric looking places, it's not immune from plastic that accumulates on their beaches. And being, I guess, an island out in the open ocean, you're going to have a lot of plastic and things that shouldn't be washing up on the beaches. And so one of the aspects of my project is to collect the plastics and survey the beaches for things that are washing up. And what I'm hoping to do is be able to analyze those plastics and look at the different polymer types, because there's at least like 7, I guess, like recognized polymers, one of those categories being other. So that could actually be a huge amount of other types. But there's types that are easier to work with and some that are not. And so things like type 1, like your PET bottles, they are able to be recycled, and there's some things going on there. But when you're on a remote island and perhaps you've got huge amounts of plastic washing up, for example, Christmas Island and the Cocos Keeling Islands up between Australia and Indonesia is one of the more extreme cases of this phenomenon. And when you've got tons and tons and tons of this stuff continuously washing up, what do you do with it? You're on an island with maybe a couple hundred or maybe 1,000 people. You're not going to have huge infrastructure. You're not going to have endless amounts of funding. So what do you do with this? And so I unfortunately don't have an answer for that right now, but come back in 3 years' time and I might. That's one of the things I'm hoping to work in. And so being able to work out what the plastics are on a molecular level with what chemicals you're working with is going to help inform the processes of what we can do there. Because this is also a human problem as well. We can't just melt all the plastics and build something out of it, because they all release chemicals and they have different temperatures, and it's, we don't want to be giving people cancer from the chemicals in the spaces where these things are going on. And so being able to know the items that you're working with on a chemical level is really important in getting that foundation. And I'm also hoping to work out in some of the sites I go to the accumulation rate. So how many items are washing up sort of, I guess, per day, week, year sort of thing, to know what's the source of what we're working with. I guess if you think of this kind of as a resource, I'm using air quotes here, but if marine plastics are a resource and you're on the receiving end and you're on an island, you can't turn that tap off. And so you have no choice but to work with that. And like Harrison said, adapt to that. And so what I'm hoping to do is lay some groundwork out for telling them what they have washing up and how much they have and what we can possibly do with that.
And of course, then linking in the impact it has on bird life.
Yeah, absolutely. There's an awful lot of flow-on problems that come from foreign items and plastic, and especially things as toxic as plastic washing up on beaches and being adrift in the ocean. And so there's quite a lot of work being done in this space by people such as Jen and in the seabird space. This project has drifted a little bit away from the bird side of things, but no doubt it will be really informative to a lot of other people working around this. But my honours project, which is the Birds and Vomit project, definitely has some interesting stuff there.
So we'll get into that. Harrison, you're doing something completely different. Tell us about what your research entails.
Yeah, so mine's a little different. Mine's so the short-tailed shearwaters, the birds that I was talking about before, they're Australia's most numerous seabird. So there's about 23 million of them, and they make an annual return migration from the breeding grounds in the North Pacific Ocean, so like Bering Sea between like North America and between Alaska and Russia, like the Bering Sea there. Yeah, so they make an annual return migration from the Bering Sea to their breeding colonies in Southeast Australia. And most of these birds, so like 18 million of them or so, breed in Tasmania. So we've got a lot of them down here. And basically they've made this migration pretty reliably, in all the years that have been recorded. And they generally arrive in around the last week of September in each year. But in 2019 and 2020, they were late in returning to their colonies, and by some cases up to 2 to 3 weeks. So that was pretty concerning, especially when some of these colonies exhibited like lower than average breeding success rates. So but kind of all this evidence about when the birds are arriving has sort of been anecdotal. It's pretty hard to survey 17 million birds and, hundreds and hundreds of colonies and work out when exactly they're arriving. It's more relied on just like, people seeing these birds come in, but, that's not their job to really collect this data. So it's more just like when they're coming in and, but it's relied on like ranges and stuff as well to telling people. But we really wanted to find a way to properly quantify this in a scientific sense. So we figured if we could put out sound recorders on shearwater colonies, maybe we could detect these birds coming in just based on their vocalisations. So what we did was we put out 10 sound recorders across 10 colonies in southern and eastern Tasmania. And just before they were meant to arrive, around about mid-September, we put them out. And then we again collect them in mid-October. So pretty much what I've been doing is just seeing whether or not we can we can use their vocalizations, time of the first vocalization and sort of like a increasing vocalization rate to see when these birds are arriving and at what rate they're arriving and if they indeed have been late. Yeah, which is kind of
So one question on that is vocalization rate based on the amount of birds in that space, or is it I don't know, how do you say it? Their talk, their communication in terms of, I don't know.
That's a great question. That's the assumption, that's the assumption that you have to put down, that an increase in vocal activity equates to an increase in density of the birds, which kind of makes sense, right? To say if you're capturing more vocalizations, then you assume that more birds are going to be there. But yeah, it's interesting. It's with vocalization rate, it's tricky. So far, my findings haven't been able to make this correlation between vocalizations and density of the shearwaters. But it's sort of more like we're concerned about when these birds are arriving, not necessarily how many are arriving in this study. So as long as we can detect when the birds are arriving, maybe future research can sort of detect.
Because I thought maybe mating season would mean there's more activity or something like that. That was where I was trying to get to.
Well, they come down to mate, so it is mating season when they get here. Yeah. True. No, it's interesting. They'll go away. They'll leave the colonies once they come down here and start mating with each other. They'll re-establishing their pair bonds is what it's called. They'll eventually leave the colonies again, and all of a sudden, from the colonies were super dead, and then all of a sudden, thousands and thousands of shearwaters are at this colony, and then 3 or so weeks later, they'll all leave again, head down to Antarctica, feed up, and then come back and then go back to the colony. So it is interesting to see these peaks and troughs in vocal activity. Yeah, it's really cool to see it.
And I imagine that kind of project is going to become increasingly important as we kind of try to scope out how climate change is affecting their movements.
For sure, yeah, and I guess it was concerning that they're quite late because there's this. It's all just kind of working theories at the moment, but there's this theory that they're becoming mistimed with their prey species in the North Pacific Ocean. So climate change is shifting the phenologies, and I use the word phenologies to mean cyclical events in an organism's life history. So that could include migration, but it also includes things like flowering, or it also includes things like breeding, things like that. So climate change is shifting the phenology of species, worldwide, right? So just say a algal bloom in the North Pacific Ocean gets shifted earlier, and then the organisms that feed on that algal bloom need to shift their phenologies earlier, and then the fish that feed on those organisms need to shift their phenologies earlier. And you can see when all these species need to shift their timings, that it can become totally out of sync. So the fact that the shearwaters are actually arriving late may not necessarily be bad, right? So if they're shifting their phenologies to match with their prey species in the North Pacific, that could be a good thing. They have this phenotypic, this plasticity that we didn't realize before. But it could also be a bad thing, right? They could be waiting, but really these prey species are never going to come. They've become mistimed with their species, and then they say, okay, well, we need to go now, otherwise we're not going to breed. And they come down to the colonies in Southeast Australia, and they have lower than average breeding successes, or there's major wrecks that occur, like major deaths of shearwaters that rock up on beaches, which did occur in 2019 and 2020. So yeah, this is all just sort of preliminary stage. This is asking the first question, can we quantify these arrival dates before we can then ask the other questions, like you said, Emma, what does this mean for the future viability of the birds?
And you're at the pointy end of that, so publishing soon, inside scoop here, or?
Watch this space. No. So I'll submit it to the uni, my thesis, but I think I still want to clean up a few things before it's ready for publication, I think. I'm also trying to build it's not going to be part of my thesis, but that I submit to the university, but I'm trying to build a call recognizer, which can sort of like automatically detect shearwater vocalisations. So far, it's been a bit of a flop. It's not hasn't been very successful, like training a machine to be able to automatically detect these vocalisations. Pretty hard with overlapping calls, and that's pretty a common sentiment in the acoustic spaces, that when there's overlapping calls, it's hard to tease apart individual vocalisations. But I'm trying to give it a crack. It's not really paying off at the moment, but I'll try for the summer, and if it doesn't work, then I'll publish it without it, I think.
So not such a relaxing summer after all. Off air we were talking and Harrison said he had big plans to just relax, but doesn't sound like it.
I'll still have a bit of it, I think.
Lil will just be happy to get out of a bedroom, out of quarantine. Now, speaking of published paper, Lil, seasonal ingestion of anthropogenic debris in an urban population of gulls. Tell us a little bit about that paper.
So this is the paper that came out of my honours project, and honours is a year-long project that you do first sort of out of undergrad. So I guess it's the first sort of dipping your toe in the world of doing research. And so, yeah, as I mentioned earlier, this project was a little bit, I guess, not typical. It was looking at gulls that live in urban areas. So for me, that was in Launceston, which is in northern Tasmania, and looking at their vomit and using that vomit as a really good indicator of what they're eating, perhaps where they might be getting that from, and looking at how they interact with things like our waste and our plastics and things like that. So when you think of gulls, like, they're not the most romanticized bird out there. I love all birds though, so that was fine. But like when you compare them with like an albatross or a penguin, like people don't go, oh my gosh, I work with gulls. I did though. I thought they were fantastic. But they're actually a pretty impressive bird. And so they can be really annoying, like when you're having your Instagram worthy picnic and you're just getting bombarded with birds that want your chips. Like it's easy to see why people aren't huge fans of them. But they are a really impressive bird, and they're what we call generalists. And that pretty much means they can live in multiple or different environments. They can adapt their diet to prey species or items that maybe are seasonal. They eat like a range of things. So they eat anything from like squid, fish, shellfish, all the way through to berries, other birds, rodents. They're a generalist. So they're pretty general with what they do and what they eat. And so this is really actually quite a cool point to talk about, because as we expand things like our cities and our urban areas and our abundance of landfills and things like that, these birds have also managed to coexist alongside us. And so when you've got an expanding urban area in a place these birds would typically call home, instead of, I guess, being driven away, they've, I guess, thrived in this space. They've absolutely nailed the living alongside humans thing. And in Tasmania, there are anecdotes from around 100 years ago where these birds would exploit the landfill sites because, I mean, there was food, it was available. They didn't have to expend much energy to find it, and it was pretty much available every day of the year. So why would you do anything else? And so fast forwarding to now, where food waste is one of the biggest waste streams in our urban spaces, we're still sending it to landfill, and the gulls have adapted to exploit this. And so I don't know about you, but if there was a buffet every day of the year, I'd be pretty keen on just exploiting that myself. And so they've stuck around, and they've not only eaten sort of things like food scraps and whatever, but they're also interacting with other items that are in these landfills or bins or places where waste accumulates. And so even though they're practically living alongside us in a lot of our cities all around the world, there's not loads of information in the scientific literature about how they interact with us and our rubbish. And at least this was the case with Tasmania, or more broadly Australia, at the time that I did this project. And so this project came about by Megan, who you featured on another episode. She was walking with the lab through the wetlands, which, so Launceston is basically a town in a big estuary river area. And so there's this beautiful wetlands, and there's loads of different birds. There's like sort of mud flats at certain times of the day. It's a tidal area, so you've got all kinds of things foraging, and it's really beautiful. It stinks, but to the eye, it's quite lovely. And so they're walking along the boardwalk, and they noticed that there was a heap of rubbish. Kind of looked like someone just emptied their pockets, and it was things like bathroom items, kitchen, I guess, food items, things that like people maybe wouldn't. I mean, I'm not sure about you, but I don't floss my teeth in a wetlands and then toss the floss pick. And so it was kind of like, how is all this getting here? And so they also found that there were these pellets on the boardwalk, and they're only about sort of this big, like the size of a 20 or a 50-cent coin. And it kind of begged the question, is this linked? And some of these pellets had blue and white and red things that didn't look very natural. And upon closer inspection, it was actually rubbish. And so these pellets are actually the regurgitated, or for the sake of this podcast, vomit pellets from the gulls. And so it was the Pacific gull. They're the largest Australian gull. I think they're quite beautiful. They've got lipstick on the end of their beak. I think they're quite funny. But they would roost in these wetlands on the boardwalk and sort of vomit up these pellets. And the pellets the pellets contain the items that they can't digest. And so the way they get rid of that is by collecting it and then sort of
it's like a cat bringing up a furball.
Basically. Yeah. I'm sure like people would be familiar with things like owl pellets. It's the same sort of thing. And so these are really cool. These are a great research tool because they tell us what the birds are eating. They can tell us things like where they might be getting that. So, for example, a lot of the pellets had things like fish bones and squid beaks. And so that might indicate they are going to sea or going to a coastal area and then coming back, whereas others had things like beetles and rodent teeth, and of course a lot of rubbish. And so that might sort of paint a picture that these birds are hanging around an urban space every now and then, sort of going around elsewhere. But one of the things that we noticed was an awful lot of these pellets had at least one item that shouldn't be there. And so this is where I come in. Over the span of a year, I collected and pulled apart hundreds of these things. It was very glamorous, and it stunk a lot. But it was really cool because I thought it was cool. And I was kind of touching on what Harrison said, where it's like, it's not great, but it is like kind of interesting to be discovering something that's happening in this space and then being able to tell the story of that. And so when we pulled apart these little vomit pellets, what we found was that more than 90% had at least one item of what we call anthropogenic debris. And that basically just means anything man-made. So for the sake of this paper, it was plastic, glass, or metal. And so more than 90% of these pellets had at least one of these items. And that was quite shocking. In some cases, I think one had over 100 pieces of polystyrene, I think. It's been a while since I've published that, so I could be wrong. Please don't judge me too harshly. But it was pretty staggering. We were finding things like knife blades and glass that was still really sharp, and all kinds of single-use plastics. And that, I think, was the biggest thing for me, was a lot of the items that we were finding, so things like plastic bags and dental floss picks and I guess like sanitary items and things like that, a lot of them were items that we use very briefly and then we sort of turf it away. And so if people perhaps found an alternative or were a little more conscious about the items that they were using, they wouldn't be appearing in the diet of these birds. And these birds are obviously kind of scavenging in areas like landfill. There was a landfill, I think, a couple of kilometres from this site. So it's not unlikely that they were feeding there. And this species has been recorded to be there basically every day foraging. So you kind of put the pieces together. We safely assumed that they were likely feeding at the tip. And
that's quite a different point here, because a lot of the time we talk about marine debris or or the way we behave in nature. We're littering or plastic bottles that get washed into waterways. But this is, we might actually think we're doing the right thing by disposing of it responsibly. I'm doing air quotes now here. And it's going into the bin, which then goes to the rubbish tip. And we also know of a lot of instances where you're doing recycling and you think it's getting recycled, and that also ends up at the tip. So it's exactly what you've said. This is most likely coming from a landfill area, a rubbish tip, which is kind of, well, now what do we do? Because I've behaved what I think is correct. I've put the rubbish in the bin. The bin has been collected. It's been taken away. I haven't littered. I haven't left it in an open bin in a park that's overflowing. I've done the right thing, but yet it's still a problem.
Yeah, it's a really interesting point that you raise, because this again is such a loaded topic, because I guess as consumers and like the general community, we oftentimes are trying to do the best we can with the options and the resources we have available. And so a lot of the time that is landfilling. And we assume that a landfill is, I guess, like a contained site, and they are designed to be that. But this is obviously an example where the system perhaps needs to maybe change or just alter a few of the things that they do, because the waste is going to a, air quote, contained spot, and then we have wildlife coming in, foraging, doing what they naturally do, and exploiting a resource that is just like Christmas for them. And then they're collecting these items, they're going to these wetlands, and this is something that this paper described, which at the time of publication was one of the first times that this had been described, and that was an animal acting as what we call a vector or a transport mechanism, collecting these items, ingesting them at the landfill, flying to a wetland environment, and wetlands are incredibly biodiverse. They're really important. They're sort of like a filter between land and sea. And oftentimes there are a lot of vulnerable or endangered species in these places. And so these birds are taking these items from a contained site, vomiting them up at their roosting site, which in this case was a wetland. And that then can basically enter the ocean. It can enter that river system and become available to a bunch of other wildlife. And so it goes from being used, contained, available again. And it's that process of going from land to aquatic environment with things like plastics through a bird, as I said, was one of the first times that had been described. And so that was really interesting. So I guess that sort of emphasizes the need to not have those items enter the waste stream in the first place.
Yeah. And that's quite timely, actually, to a topic that's been in the news over the last couple of days at the time of recording this. Obviously, it'll be old news by the time this episode's out. But have either of you seen in the news the ocean cleanup and how much plastic they've been getting from the marine garbage patch in the Pacific?
I think I came across an article this morning, but I have been
Emma's just put it in the chat before you guys came online. Here's a bit of behind the scenes for our listeners. We do use the chat, and we have a bit of offline chat. But Emma put the chat.
So they've recently gathered 9,000 kilograms and taken it away from the garbage patch in the Pacific. But a really good point of one of the articles was that, that's fantastic. But if we continue on down the track we are now with like landfill management, it's kind of like, well, that's great.
And it goes, and it's the other point of what do you actually deem as contained? It might be contained from, heavy rain, and then that's washing, there's a landslip or it washes into our waterways. It might be contained from those kind of perspectives. But like you say, Lil, but now here's a bird flying over the fence, over the wall, over the barricade, picking up the stuff and taking it away. So it's not contained from certain elements, and that is, like you say, wildlife. So there's a disconnect there, and that's what you're finding through your research.
Yeah, absolutely. And I guess another one of the outcomes of this study, which I'm really proud of, this was a really great project. There was a lot of collaboration from different community groups and members of the lab and the university. And one of the things we were able to do was take this project, because we could sort of collect these little pellets. They're quite fun to dig around with. It's always kind of like a little treasure hunt of what you're going to find. But we could do demonstrations with these for things like school groups. And basically what we would do is we would be like, all right, here's a little vomit pellet, and this is the story behind it and what, in a biological sense, what's going on. And then we'd sort of do let's see what we can find. And a lot of times you find things like bread clips or plastic bags. A lot of the time things are quite intact, so they still have logos and that sort of stuff on them. So you can really identify what you're looking at. And a lot of the time you can sort of be like, okay, so who's used one of these, in the last couple of weeks or year or something like that? Or is this an item that you recognize from your house? And a lot of the time the answer was yes, myself included. And when you see something that you could have personally used and then has now ended up in a natural environment where it's become a hazard again, it sort of there's a bit of an emotional connection there, and being able to, in a constructive way, get that emotional connection, especially with people like children and school groups that are, you know, I kind of hate to say, but they're the ones that are going to have to work harder than we are to sort of fix what's been done. And so, yeah, when you're able to show kids what's going on, they are really receptive to that. And we had heaps of fun with this. And so through doing it with school groups, we saw that they'd recognise things like plastic spoons and cutlery and straws and things like that that they might use at their school canteen. And so they got around their school and we're like, all right, well, the birds are eating this, so we're going to get rid of this from our menu or from our canteen and that sort of thing. And so we're able to see some really tangible, positive change in people finding alternatives, not using it, and talking about it a little bit more.
I have to say that Carly didn't show the same level of enthusiasm picking up poo, or in scientific terms, guano. So maybe that's where she's gone wrong. Vomit is better than poo. Who knew?
I did go with her when she went out on one of her little scoping trips. And when we got the first poo, we'd waited probably about 45 minutes. We're sitting there just literally with binoculars fixated on these birds. And I know she said that they were doing all kinds of things like mating and having a grand old time. We're just sort of perving on them the whole time. That was quite funny. But when she got the first poo, she was so excited. She did a happy dance. It was great.
Yeah. She actually did mention that story and started going down a bit of a rabbit hole. We kind of had to cut that one short. But but who knew picking up vomit was such a thrill in the science world? You know, maybe that's where I went wrong when trying to decide what to study. So, Harrison?
I was just going to say it's really important to be accountable for the decisions you make at the supermarket and elsewhere, for sure. But the onus isn't just on the consumer. You know, we need to put pressure on policymakers and the production line as well. Like, you know, the fact that Woolies can have little ushies that you can win small little balls of plastic for your child, like, it's ridiculous. So I definitely think that there is onus on the consumer, but I don't subscribe to this whole idea that things need to change higher up than us, and it needs to change with us and higher up. Yeah, for sure.
Well, it's also a big picture of the food system. You know, I mean, those little goodies you can get are usually meals that are not good for our health either. You know, so there's a whole flow-on effect around that. But you know, what's been fascinating listening to this so far is that we so often think about direct pollution of the water. So what I mean by that is plastics, especially, that goes into a waterway somewhere, whether it's a river, stormwater, wetlands, whatever, and ends up in the oceans, breaks down into nano and microparticles. But this is completely different now. This is, like I've said before, and I don't want to repeat myself, but there's another angle of how this enters the ecosystem. And these gulls, for instance, are an enabler. I mean, we are already. I mean, we've started the problem, but they are taking it from a landfill. It's going through them, so it's causing issues for them, for the gull. They vomit it up, and now they've brought it into that ecosystem, the wetland, the ocean, the lakes, wherever they are. So it just adds another level of complexity, and I love this whole concept of engaging kids, especially in schools. And here's some vomit, dig your fingers in, see what's in there. But it's really, it's that whole awareness thing, and it's the self-realization of what's actually happening by directly being involved in part of that, you know, seeing what's actually happening.
Yeah, absolutely. I know when I was a lot younger, having a very hands-on approach to science, and I guess some of the bigger pressing issues definitely made a difference for me and probably contributed to where I am now. So you're absolutely right there.
Yep. Having a hands-on approach to your chickens. Now you're working with birds. So
yeah, still love them.
So tell us a little bit more about your current work now, Lil, because you've obviously moved a little bit away from bird poo, or vomit, sorry. Either way, tell us more the focus now on what you're doing. You've given us an introduction looking at the type of polymers and so on, but what's part of the whole process around that?
So I guess as I am only just a little way into this, there's only a limited amount of what I can sort of say, as I'm still very much learning the process as I go along. But it's doing a PhD project I think it's quite cool, because a lot of times you're working on like one sort of topic, but you break it down into sort of different elements of that topic. And so for me, I don't at all have a chemistry background or an analytical background or analytical bone in my body. And I'm now going down a chemical science pathway and looking at things like the molecular structures of plastics using some very expensive lab equipment and some really cool techniques. One of them is FTIR, or Fourier transform infrared spectroscopy, bit of a mouthful. And so I've never done any of this. And so again, this is me learning something fresh and something new and something that's actually applicable in an industry, a real world, and a community sense. It's, I guess, very techie sort of stuff, but when you then put it all together in the bigger picture, it's really important stuff. And so doing things like that is something that I'm working towards. Also, another element to my project is there's an awful lot of collaboration involved. So a lot of the times these projects are not just a supervisor team and a student. A lot of the times it's people from the communities, if you're doing things like field work, that are really valuable and have a lot of local knowledge and lived experiences that you'll work with. And it might be collaborators on the other side of the world who have a technology that you might not have even heard before, but they're looking for an application to try that technology, and you're looking for a new way of recording something and describing something. So that's another aspect of my project, something which I'm hoping to get to in the next 1 to 2 years. And then what I'm currently working on, it's not overly exciting at the moment, but it's a literature review. So I'm doing a lot of desk-based work. It's not all Lord Howe Island trips and tropical islands, unfortunately, but that's okay. So I'm doing a literature review currently looking at the state of waste management on remote islands and in remote areas in Australia. And so Lord Howe Island is going to be one of those case studies that I look at. I've only just started it, so I'm very sorry. I don't have any juicy information to tell you yet, but it is really interesting, I guess, looking at the country in a broad sense, particularly with a remote lens, I guess, on it, and seeing sort of maybe how far some places have come, where other places are at, the challenges that are associated with managing things like waste, which we can't avoid in a remote setting when you've got limited resources, limited people, limited money, things like that. And of course, things like transporting and freight and biosecurity. There's a whole range of factors we have to consider here on how to have a bit more of a holistic approach there. And so I guess, yeah, that's where I'm at.
Speaking of collaborative approaches, Harrison, how important is, I mean, you've only just started with your research. I guess maybe a two-pronged approach here with this question, or two parts to it. But one, are you hoping to take this kind of research and apply it to other birds in other parts of Australia? But then how important is local knowledge as part of, I guess, the data? People that have always lived in a particular area that know more of the trends and so on. I mean, that's also quite important. Local, on the ground communities engaging.
Yeah, it's interesting. So for the first point, I would be very curious to see if that the methods that I apply here can be applied for other birds. And so it has been, the methods that I've applied here have been used for other birds, for songbirds, but it's not necessarily for seabirds. And that's because seabird colonies have a whole host of unique challenges, right? They can be really, really windy because they're usually on headlands. And usually there can be other species that are calling at the same time, like penguins, for instance. So it would be interesting to see if we can use these methods on other seabirds. My gut feel is yes. If they can work for short-tailed shearwaters, then they probably can work for other burrow nesting seabirds as well, so long as they have similar structures in their vocalisations. But yeah, it'd be something that, yeah, if I don't test, hopefully someone can cite my paper and test themselves. And for the second part of the question, yeah, it is, and it's really important. Definitely local knowledge as well, and I. Yeah, definitely don't want to dismiss the fact, and I was worried that maybe I did before, that the fact that just because it isn't necessarily anecdotal or like quantified, that it isn't accurate, because without local knowledge, we wouldn't have known that the birds were arriving 2 weeks late, 2-3 weeks late.
And then local indigenous, this is adding another level, local indigenous knowledge. We're talking about centuries of knowledge, or that could be swayed by urbanization and all sorts of other complexities added to that. But yeah, that would be a component. That would be something you would not ignore. You'd certainly incorporate It's just to what degree and where you're at, and it's all the variables.
Yeah, it would be fantastic to work with, local Indigenous communities for sure, especially because short-tailed shearwaters mean so much culturally to the Indigenous people of Tasmania, with their harvesting every year. And yeah, it's just, it would be great. It would be great to head to Flinders Island or something like that and get their insight. It would be an amazing experience, and I'm sure I would learn a whole lot.
And there's an interesting point to be made there as well, in that shearwaters, I guess, generally speaking, they've got some of the highest rates of plastic ingestion. I'm not an actual seabird person, so I'm not sure if that's 100% correct, but they are eating an awful lot of plastic. And so when you look at the work that's being done in the human health space from things like fish or like top predators that are having contaminants and pollutants in their system, and then we harvest and eat those, there are issues there, and it's an emerging field, but there's already some red flags being raised. And so when you're looking at Indigenous communities that are going and have it, like, doing their cultural practices that they've been doing for thousands and thousands of years sustainably in perfect balance, you've now got a human risk element to that. And I find it quite heartbreaking to see the impact on Indigenous communities and Indigenous people who they've been the original scientists for thousands of years, managing but also coexisting as part of nature rather than being apart from it. And I just think that's such a beautiful thing. And to see how that's rapidly changing in the way, I mean, that's also, we could probably have another 3 podcasts on that topic, but just to see how things aren't the same as they used to be because of a very short period of time where we've kind of made some poor decisions as a human race. That's a space that's also quite loaded.
Yeah, really important points to raise, Lil. So Harrison, as this is kind of like the first step in multiple steps, hopefully, you're towards the end of your honours. Do you think you'd want to continue on with the same topic and continue it into a PhD topic, or you just want to chill out over the summer and do some thinking on that?
Oh, no, I'm thinking about it every day. It's interesting. It's hard to know what kind of space to move into next, whether or not I stay with a bioacoustic lens, or whether I stay with short-tailed shearwaters and seabirds, or both. I don't know. I would love to. I would love to. I've got one song meter out now, and that would be interesting to have a look at this data from this year. But yeah, I'm not exactly sure. Bioacoustics has really gotten a little hold on me this year, so it would be interesting to, particularly build this core recognizer. I want to see if it is actually viable, and if it is, has big implications for researching seabirds acoustically. So I think maybe I'll spend the summer trying to build this recognizer, and if it is successful, then maybe make a decision then. I'm not too sure. Cool. I've got some thinking to do, but it's exciting. I definitely want to stay in the broad space that I'm in now, but I don't exactly know which direction to take it in.
Don't worry, and probably in 20 years' time, you still won't know what you want to be you grow up. So
that's right.
That's all of us. Lil, what's your big picture goal, other than changing the world? You're involved in
other than
some
that. Nothing too big.
Nothing too big. My big picture goal is, see, I'm such an indecisive person. I just don't know what I'm doing half the time or what I want to be doing. I kind of do it. For me, I think to know that I've personally done what I could and been able to use my privileges, my opportunities in the space that I'm in to encourage other people to also maybe either make changes or just be aware of the bigger picture things that are going on. I think if I'd done all this work and perhaps not communicated things effectively enough, or had conversations with people that those conversations kind of need to be had with, I think that's where I'm at. I just want to know that I've done what I could and all that I could to the best of my ability. I'm not sure if that's quite where you wanted that question to go, but I don't really have an end goal. I mean, I'd love to see plastic out of the oceans, but let's face it, that's not happening. We're dumping millions and millions and millions of tons of it every single year. And so I think that's a little bit too optimistic, but I think I would just like to see things start going a little bit better than they are, I think.
Yeah, I think, Lil's answer help me frame my own answer to the question. I think it'll be nice to devise a monitoring technique that we can. It would be nice to devise a monitoring technique where we can reduce the disturbances on the birds, and I think acoustic monitoring definitely provides scope for that. Yeah.
And we asked this of our last Adrift Lab students, but bit of a plug for Adrift Lab. What's it like as a student for potential students that are looking into this? You've piqued their interest. They're really keen to get into this space. Let's talk them up.
Absolutely love it. It's a really great lab to be a part of. I think the big thing is support. Lil touched on it earlier, but just having like-minded people that you can rely on and that you can support them and they can support you. It's invaluable. And just like availability, I think as well, availability of Jen and availability of the other students in there to be able to talk about your research and just about life and how you're coping. And just, we have a really good, strong culture, and we'll go out and do events together, or we'll go out and go to the shearwater colony together, which we did recently. It's just, a really great group of people, and I'm so happy to be part of the lab.
Yeah, I think that's covered things pretty nicely there. But I mean, I cannot sing enough praise to Jen for the lab that she's created and the environment that she promotes, because yes, it's a heavy area to be researching. Like our sort of core goal is plastics, seabirds, and sort of what's going on with the ocean. But in that, I mean, a lot of the time there's some pretty depressing things going around, and so it's nice to be able to know that I can cry in front of any lab member, judgment free. Done that many times already, and that's totally acceptable. It's healthy. But I guess maybe one of the more like lighthearted things to talk about is, with such a diverse range of projects going on, we've got PhDs, masters, honours, postdocs, basically every level of research, whether you're just starting out or you're sort of into your career, there's likely sort of somewhere where you will fit in. And you've also got the opportunity to not only just hang out with each other and talk about what you're doing and learn from each other, but I mean, I've been able to volunteer on a range of projects outside of mine, like Harrison's, which is on Bruny Island. One of his sites is on Bruny Island, which is a pretty cool place. If you're ever in Tasmania, check it out. It is delightful. And so I've picked up skills there. I've gone out with Carly on the binoculars, watching birds poo. I'm not sure how that one's going to stand up on the resume too much, but it's enjoyable and it's fascinating, and you learn a really diverse skill set. And I know that Jen is a fabulous researcher. She's equally a fabulous human being. And the level of support that we receive through Adrift Lab is just phenomenal. We're inclusive, we're diverse, and we're a bit quirky sometimes. And I just think that's fantastic. I wouldn't have it any other way.
What a way to wrap up. Thanks, Lil. Job done. But look, I think I just want to say that the future honestly is bright. We went down this dark rabbit hole early on in the episode about eco grief and so on. But, when we started off as a podcast, just like a lot of others, we wanted to be evidence-based. We wanted to interview people that are established and know what they're talking about. But honestly, it's been such a breath of fresh air having the likes of yourselves. We don't need someone to have 20 years of experience to teach us. We don't need someone of 30, 40 years of experience to actually know what they're talking about. You have both. A common theme for me on this episode has been all about communication, and that is something that the two of you do remarkably well. And it's an important component of the work you do now, more so than it was before. Maybe that's why, we're finding more people like yourselves, still studying, still researching. But it's been an absolute delight. I've learned an incredible amount. This journey just in the last hour has been fun. Science is fun. We need more people in science. So firstly, Lil, Harrison, thank you so much for making time to come onto the show. We wish you the best of luck now in real time over the next couple of weeks to finish off the year. But in virtual time, with whatever you choose to do, we know you're both going to continue to be even bigger successes. We really hope to follow some of your future papers and all that. So again, thank you so much. And it's been a real pleasure.
Thank you so much, guys. This has just been fantastic. I mean, another little plug here for you guys, just being able to communicate what we do in through a lot of different ways, such as podcasts, is just fantastic. So you've helped us as well. Thank you.
Yeah, it's been a hoot. Thanks heaps.
Thank you for listening to the Lentil Intervention podcast. If you found this interesting, make sure you subscribe and share it with your friends.